Hello everyone, my name is Yashvi Sharma and today I'm going to talk about how to make music player using Doubly Linked List. So before I begin with Doubly Linked List, let's talk about what is linked list. So linked list is actually a data structure, a linear data structure which looks like a chain. So it has it has a component called as node. These nodes stores the data or information. Like for example, here it can store 1 and it can store 2. Now these nodes will point to the next node after it, or the a node after it. Pointing to the next node means that this node, like particularly this one node, will store the address of the next node, that is of the 2 node. Now the last node within this linked list stores nothing, or we can call it as a stores none. None means it would store nothing. Now additionally there's a pointer called as head, that will store the address of the first node. This is how our linked list looks like. In short, it has components called as node which stores the information as well as the address of the next node. The first node is always pointed by a head node which stores its address, and the last node will always store nothing, or or will never point anything at the last. Thus, we will consider it as none. Now, there were actually two problems with linked list, which is first, when we traverse through the list to access the last node, it becomes hard for us because it increases the time complexity. What I'm trying to say is, when we insert the node at the first or delete the node from the first, it is very easier for us to move the head pointer to the next and delete it or insert any other node. So this actually happens in O1 time, but for accessing the last element or deleting it, we need to traverse through the list at the last and then delete or insert at that position. It becomes from O1 to ON for the last element to be deleted or inserted. Second problem was that, for example, if there was 3 nodes and we wanted to there's a node which is pointing at the middle node. Now I wanted to access the previous node. Now to go back to the previous node, it becomes hard for us to access its data. For example, what I'm trying to say is that here we are having 2 nodes. For example, if we had 3 nodes, instead of none we had 3 nodes, and this node was being pointed at by some pointer, let's say P. Now to retrieve the data from this node becomes hard for us, because now we have to maintain an additional pointer which will point at it. So if this pointer is pointing, now we need to move, we can't move it, so we need an additional pointer pointing it to access the previous node. So it becomes very hard for us, as we have to traverse through the list to point at a previous node. So these things kind of become hard for us in linked list. To overcome it, we have another type of a linked list called as doubly linked list. So what happens in doubly linked list? For example, we have these 2 nodes. Just like linked list, we will have our first node to be pointed by head only, and last node will be pointed by will be pointing to none. What is different in doubly linked list is that Now this node will not only point to the next node, but now this node will point to its previous node. Thus, it becomes easier for us to access the previous node's data without actually traversing through the linked list. Also, in the doubly linked list, we sometimes have or make an additional pointer called as tail. I'm sorry. Which is like a pointer at the end of the list. So if we want to delete or insert anything from the doubly linked list, it's become very easy for us to delete from the last element or insert an element without traversing through the last element. So this is how a doubly linked list looks like. So if I put it in a very single sentence about the doubly linked list, it is that a doubly linked list is a type of a linked list which have nodes not only pointing to the next node but also to their previous node. Now, just like a linked list, we have operation called as insertion, deletion, traversing in doubly linked list also. So the doubly linked list have insertion of three types, just like linked list, that is insertion at first, insertion at anywhere, and insertion at last. Inserting the new node in doubly linked list is kind of similar to the insertion at first in linked list only. What we do is create a temporary variable called as, for example, temp, and this will store the node. Now what we will do is keep this node. Now what we will do is we will point this node next to the head. As we know, the first node will always have head pointing to it. Now after this, we will let head.previous be pointing at temp, which will look like temp.next will be pointing to head, and head.previous would be pointing to temp. Now we will move this head to the new node, and this will be pointing at head. Thus, head will become our temp. This is how we insert any node at first. So insertion at anywhere also is very similar to the insertion at in linked list. So what we will do is we will let temp.next point to cur.next. Imagine there is already a pointer known as cur here. So now what we will do is we try to let this temp point to cur.next. Now this cur.next.previous will now be pointing at temp instead of cur. Then we will let cur point at temp, and then temp.previous would be pointing at cur. So if I write it here, it will look like temp.next would be cur.next, cur.next.previous would point at temp, cur.next would point at temp, and then temp.previous would point at cur. This is how our insertion at anywhere would look like. Now insertion is at last is very different from insertion at last in linked list, because in here first we need to maintain a additional pointer called as tail. Additional pointer called as tail pointer, and this will actually be pointing at our last node. So what I'm talking is, for example, we have this doubly linked list. Now not only head will be pointing here, but we will have an additional pointer called as tail that will be pointing here. So it becomes easier for us to delete because then now we do not have to traverse through the linked list in order to get the last element. So insertion and delete would look like that. We would again, insertion at the end would look like we would again make a new node. Now this new node will be pointing, so temp.previous would be pointing to tail, tail dot next will be pointing at temp, and temp would be then temp dot next would be pointing at none. Now this will help us in inserting new node without actually having an additional pointer. Just like insertion, we also have deletion at first, deletion at anywhere, and deletion at last. Deletion at first and deletion at anywhere is again similar to linked list. So in deletion at first, what we do is we have two nodes. We will move the head pointer of here to the next node. So what it will be like that, head will become this. We have two, for example. So this one we will move the, for example, if we want to delete this middle one, this pointer point at this one, and this pointer point at this one. This will lead to this have a breakage. So simply if I say, we will let for example, it was at position 3, so what we will do is maintain this curve, and this we will do so what we will do is we actually will let this point at the node that we want to delete, and now we will do is cur dot previous dot next would be equal to cur dot next. So this previous node will now point at this one, and cur dot next dot previous will become cur dot previous. Now we do not have to have an additional pointer previously at anywhere to delete it. Now just like in insertion at last in doubly linked list, we can access the last link, the last one using tail reference. Now to delete it, what we will do is we will let tail dot previous equal to none, tail dot previous dot next actually to none. This will happen, the previous element will now point at none instead of the last element, and we will make tail point to the tail dot previous. Now tail will point at the previous element, and the previous element will now point at none, making it the last element deleted. So this is how our insertion and deletion would look like in doubly linked list. There's one more thing which we call as traversing, and traversing is kind of displaying all the element by going one by one to another, and it is actually same for linked list and doubly linked list. We create a pointer called as cur, and we will what we will do is we will let it print out the data of the node it is pointing at. After it kind of prints out the data, we will move it to the next data, then do the same with it, and it will continue to move to last node until the next node is not none, or it is not pointing to at none. So now let's talk about my topic called as music player. So what is music player? We have seen in day-to-day life that in music player we have the symbol called as this one, pause button, and this one. So this actually is our previous button. This is our next button. So in real life also we use doubly linked list in music player. As you can see, we are using previous and next, and it is very easier to go from here and there in the music player. So in our music player we are using doubly linked list, and in my music player we are not only using previous and next, we are also doing insertion, deletion and display. So let's now talk about the code. So now we will try to make a music player using doubly linked list. So the first thing we will do is we will import a library called as Pygame. Pygame is actually a library which helps us with a kind of a lot of things related to animation as well as music and sounds. So here, because we need music, I am importing this library. Next we will be importing a library called as OS, because it helps in it will help us in adding and deleting files from our system. That is why this OS library or operating system library is being imported. Now the first thing we will do is create a class called node, and within it we will have self as well as file path set to as none. I am setting file path as none because here our file path is actually our data. Now self file path would be file path, and self dot song name would be our OS dot path dot base name dot file path if file path else none. So by this actually what I'm trying to do is I'm making a variable such that we might have a very long name for our file, and to kind of have its base name only, we will use file path variable and store it in song name. Now the main essential component comes in, that is self dot next, which we will set at none, and self dot previous, which we will again set at none. We are not initializing these pointers at anything, but we are just trying to put them in none, because when the new node will be created, it will be pointing to the next previous accordingly. Now after this we will make a class called Doubly Linked List. Now as I told, we have to make an additional class and store the some information like head, tail and current in it, because we need them for first and last element. So we will do self dot head equal to none, self dot tail equal to none, and self dot current also equal to none. Now we will create functions like append. Append means we will add a song. Self file path, because that is what our variable is. So new node would be equal to node and file path. So we are storing the new node name or data in new node. If self dot head is none, that means if there is the linked list is empty, what we will do is self dot head, let the head point at new node. Then we will let self dot tail, that is the last node, also point at new node, because there would be one element and both the pointer will be pointing at tail, pointing at new node. And self dot current, again an additional pointer, will be new node. Else, like if there are elements, then self dot tail dot next equal to new node. We are actually what we are doing, we are adding the song from the last and not the front, because it's a playlist. We are creating first come first service for it. Like the first element which is being inserted is the at the top, and then the next and the next. So the last element will be the new node. So now new node dot previous equal to self dot tail, and self dot tail, that is our tail pointer, will now be pointing to new node. Now deletion. Now deletion here we're not doing specifically from last or front, but from anywhere. So now song name was the variable which was storing the name of a song. So we will ask for the user for the input, and we will let the user enter the song name to be deleted. So what we will do is make temp equal to self dot head, and it will traverse until it is not pointing at none. So if temp dot song name equal to song name, what we will do is make self dot head equal to none. Oh, wait a minute. And what we will do, so we are doing if the temp, the data which temp is pointing at and the song name is actually the same, what we will do, we will make another condition called as temp, and we will let us see that this means if there is only one element in the list, what we will do is just simply make head equal to none, as well as self dot tail point at none. What this will do is there was only one element in the linked list. Now head and tail will point at none, thus it will get deleted. Also we will make self dot current point at none. If temp is equal to self dot head, like the data we wanted to have is the actually first element only, then we will make as is self dot head equal to self dot head dot next. This is actually what we are doing is deletion at first, which I explained. So now we will make self dot head dot previous point at none. So what it will do is now head will shift to the next element and its previous would point at none. So now the first element would be easily get deleted. Second last condition is that what if temp is actually equal to self dot tail, that is the last element. So what we will do is let self dot tail point at self dot tail dot previous, that is the previous. Now tail will point at the previous element, and self dot tail dot next, that means now the next will become null, thus deleting the last element. Last or our base condition is that temp, what if temp dot previous, like if it is not the first element, not the last element, and it is not even empty, then what we will do is temp dot previous dot next will become temp dot next, and temp dot next dot previous will become temp dot previous. So now temp will get deleted and the previous will point at the next one, and next one will be pointing at the previous one, but the temp node will not be pointed at by anyone, neither the next one nor the previous one, thus kind of deleting it. Now we will have another condition, which is if self dot current equal to temp, self dot current equal to, it will become self dot head. So we will reset the head after deletion, and we will print f is for formatting, deleted, and then song name. Now we will return nothing, make temp equal to temp dot next, and print f for formatting, song name not found in the playlist. This is how we will delete it. Now we will make another function called as self current or play current. Let's say play current, and this is for if self dot current, like to play the current song, if self dot current is like not played right now, like the current is not available, what we will try is we will try to do pygame mixer dot music dot load. So we will load the self dot current dot file path. We will load the file path which was getting stored, and another, then what we will do is we will do pygame dot mixer dot music dot play. We will let what we will do is we will load the song in the current and then play it using pygame. Then we will print f now playing, and whatever will be the self dot current dot song name. Another thing we will do is use an except, that is for what if we have there kind of an pygame error occurs, we will print error playing the song, please make sure file is an mp3 and exists. Now this will let us kind of have an error message. What if the pygame doesn't get used properly, or there is an error in pygame? next we will, else condition would be no songs to play if there is no song. Then we will make a simple next for a next button or next, which will be if self dot current and self dot current dot next. That means they both are not none. Like not only current has some value, current dot next also has some value. We will make self dot current equal to self dot current dot next, so that now the next will be played, and we will play self dot play current. Else what we will do is print no more songs in the playlist. Similarly, we will make for previous also. It is very similar to the next. Just what we will do is check if previous is available or not, and then self dot current will be pointing to the previous, and if it is not there, no more songs in the playlist. Now to display. For displaying we need to traverse the linked list. So what we will do is make temp equal to self dot head, a new variable or a pointer which will be pointing at the first node, and if temp is not none, like because we will traverse it, if it comes at last or none, then it needs to be stopped. So what we will do is print playlist is empty. If we are not pointing at anything, it will print playlist is empty, and we will return nothing. Return and print playlist. But now we will traverse it. If it is not not empty, then we need to traverse it. So current, the marker that we will choose for current is this one, and what we will do is say current, current. Now if current or if temp, because we are storing temp is equal to self dot current else it will print nothing. Now to print the songs, we will use format temp dot song name and current marker, and this after this we will do temp equal to temp dot next, so that it moves from one node to another. So this is how our basic structure would look like, and this is how our basic structure is looking like. Now I'm going to make a menu. I will make it bit in 5 minutes and come back to you. So I've made this menu and input this choices. Now let's try to play it. So first is add song. I will add a song, name night.mp3. Let's see if it is added in the list or not by using 6, that is display playlist. Yes, that is added. Now I will add another song, which is uh, travel.mp3. Again, let's see if it is added. Yes, it was added. Now we will play the current song. It is playing. Now what if I want to play the next song? I will use 3 and it will get played. Now what if I want to play the previous song? I will do 4 again. Now if I want to delete a song, I will use 5, and song to be deleted would be travel.mp3. Now let's see if it is in the list or not. It is not. By 7 I will exit. This is how my basic structure of music player looks like. I actually have made this in both command line as well as an interface. So I will show you the same code that I have used in interface 1 also. Here is the code that I used for my interface 1 using Tkinter, Pygame and OS, and it is here. Again, here also I have used append, delete, current, next and previous, as well as I have made pause and stop using Pygame mixer. Now I will showcase you the Tkinter one that I made. I've made the user interface using Tkinter. This is how my music player looks like, and we can add, delete, display from here. For example, we are playing next song and previous song. I can also pause a song and then click to next. I can also display using the display command that I gave, and I can also add another song. For example, again I want to add night. New song is added. It can be seen here. Then I can also delete a song. What if I want to delete night? Travel.mp3. If I see, there is no travel.mp3 now. So this is how my music player actually looks like. I have created the interface using Tkinter, and it was kind of a long procedure, so I couldn't give you the code of code. I couldn't explain you because it will take me more than 2 or 3 hours, 2 hours at least, to explain the code. So this is how my music player looks like, and I hope you liked it, and I hope this code was explained well by me. So if you like the code and the video,